Hello, welcome to the session. So, today in this video, we will try to solve the problems on the solids. In the condition will be when the axis of the solid is perpendicular to both HP and VP, perpendicular to both HP and VP. In previous videos, we have seen how to solve the problems or how to draw the prism, pyramid, cylinder and cone when its axis is perpendicular to HP and when its axis is perpendicular to VP. And today in this video session we will see how to construct a pyramid, a prism, a cylinder and a cone when its axis is perpendicular to both HP and VP. Now here I want to show one problem here I want to show, that is a regular hexagonal pyramid of base 30 mm side and length 70 mm long lies on HP on one of its corner of the base such that its axis is perpendicular to both HP and VP, and in this position you have to draw the projections. So here the given object is a hexagonal pyramid and base side is 30 mm and the length is 70 mm, and the condition is that axis is perpendicular to both HP and VP, and again the second condition is resting on one of its corner of the base on HP. Okay, so now you know how to construct the hexagon and all. Now the corner has to be on the HP. So first you can draw the XY line, reference line, or afterwards also you can draw as you wish, no problem. Now here I will draw the XY line. You can draw the XY line after constructing the hexagon also, or even in the initial also, okay. So now, this is the reference line, XY reference line. So now the position of the hexagon is such that resting with its corner means then the diagonal should be in vertical position. Draw one reference line and using template to construct the hexagon. So place here using that reference line, and such that the base side is 30 mm, it lies on the XY line with the reference line. Okay, now in this position mark the points, okay, 6 points. Then you have to join all these points in order. So now let me join here. So first side, second, third side, fourth, fifth side, and this is the last side. Okay, so now it is a hexagonal pyramid. As it is a pyramid, you have to join all the corners with the center, but in the case of prism it is not necessary, but whereas in the case of pyramid and cone you have to join all these corners with the center. The cone will not have any corner, but you are dividing the circle into so many parts. Those points itself you should consider it as a corner. So now let me mark the notations here. I will take first point here, A dash dash, B dash dash, C dash dash, D dash dash, E dash dash, F dash dash. Okay, so that is notations in the side view. Now first you are drawing true shape in the side view, because the axis is inclined to both HP and VP. When axis is inclined to both HP and VP, you will be getting the true shape in the side view. Okay, that you know all those things. So when axis is perpendicular to HP, you will be getting true shape in the top view. When axis is perpendicular to VP, you are getting true shape in the front view. When axis is perpendicular to both HP and VP, you are getting true shape in the side view. So now you have drawn the side view. Now at convenient distance, X dash and Y dash, and now you have to obtain the front view and top view from the side view. So now if you want to draw the side view from the front view and the top view, you are to draw the projectors up to the 45 degrees line, then upwards. Now it is in reverse. Now mark the 45 degrees line. And join with the intersection point O. Thin line. Now this is the intersection. Now I have to draw the projections downwards, opposite to the previous processes. So here downwards. You can show the arrow marks downwards. Right. Again horizontal projectors, opposite direction. Don't draw full length lines, only draw up to certain distance. Now, so here you can see all these are in opposite direction, because you are obtaining the top view from the side view. Similarly, for to obtain the front view also, draw the projectors from the side view. Only up to small distance. Now at convenient place, draw the vertical line. Sometimes if the distance is given, according to distance you can draw that reference line. If distance is not given, conveniently you can draw. So now before this, so you have to project the axis line also, center line also you have to project. You know how to represent the axis line. Long line, gap, small dash. So now what is the length of the pyramid? 70 mm. From here mark 70 mm. Now you have to join all these points with this apex, that is vertex point. That is front view. Similarly, here also the same distance. So we are getting on the center line. This is center line. Here also again you can show long line dash. Now join the edges. Now coming to notations. So now for top view, looking from the top view, notations looking from the top. So now which is visible? E is visible, D is visible, C is visible. Which is not visible? A is not visible, B is not visible, F is not visible. That is notations in top view. Now notations in front view, looking from here. This is O dash. So which is visible? D dash visible, C dash visible, B dash visible, A dash visible. Which is not visible here? F dash not visible, E dash not visible. That's all. Okay, now you can show the dimensions here. You can show the dimension. So what is this length? How much? Length is 70 mm. So how much side? Side is 30. 30. That's good. So that completes the problem. Regular hexagonal pyramid of base 30 mm side, length 70 mm, lies on HP on one of its corner of the base such that axis perpendicular to both HP and VP. So HP and VP, true shape is in side view. From side view we are getting top view and front view. That's all. Okay. That is about the regular hexagon. So similarly, so now let us see another problem, that is projections of a right circular cone of 50 mm diameter and altitude 60 mm resting in HP such that its axis is 35 mm above the HP and its base is 25 mm in front of VP. The axis of the cone is perpendicular to both HP and VP. That is the problem. So here the object is a cone, diameter is 50 mm, altitude is 60 mm, and its axis is 35 mm above HP, 25 mm in front of VP. Okay, but main condition is axis perpendicular to both HP and VP. And axis is perpendicular to both HP and VP, true shape is obtaining in side view. So for this, first draw the axis lines. Axis line, that is reference lines, not axis line, reference line. So that is XY line, horizontal reference line. And similarly, vertical reference line. Okay. Now intersection point is O. Now this horizontal reference line is XY. So vertical reference line is X dash and Y dash. Right. Now here the axis, the center of the base is 35 mm above HP. So from here, from the reference line XY line at a distance of 35 mm, mark the point and draw the axis line, horizontal axis line. Horizontal axis line. Then again, so the distance, okay, then anywhere you can take the vertical axis line. Now this intersection point, that is O dash dash here, a center. So how much is the diameter? 50 mm diameter. So 25 mm is radius. With 25 mm radius, draw a thick circle. Right. After drawing the circle, divide the circle into any number of equal parts. So let us divide 8 equal parts. That is, one has 45 degrees, 90 degrees, then 135 degrees and 180 degrees. Now join all these points, thin line, very thin line. But actually here in this type of problem, the division is not necessary, but just for making you the habit of dividing the circle, or to know how to divide the base and all. So I am making comments. So now after dividing, mark the notations here. So let me take here A dash dash, B dash dash, C dash dash, D dash dash, E dash dash, F dash dash, G dash dash, H and dash dash. Okay, now it is O dash dash. That is side view. Now, so you have to draw the 45 degrees inclined line intersection of xy and x dash y dash. So using protractor, so 45 degrees line, then draw the inclined line, thin line, very thin line, right. Now to draw the projections from these points downwards, because after the side view you are going to obtain the front view and the top view. Projectors downwards. So you can show the arrow marks. Right. Now again horizontal projectors. Only up to some length. Don't draw the full lines. Very thin lines. Right. Similarly, to obtain the front view, also horizontal projectors. Which itself axis line. Then here within the object thick line. This is the projector. Again, what is the length given? 60 mm. On the axis line, take 60 mm length. So here also on this axis line itself, you can take 60 mm. Now join on these points. Thin line, very thin. Only outside thick. Even inside lines, even if you are not joined, no problem. These are thin lines. If you are not joined also, no problem. Similarly, on the outside, thick. Inside lines, thin lines. Like this. So one more. Like this. So now coming to the notations. So now for top view, looking from the top, which are visible here, you can draw the arrow marks. Opposite direction. Now A is visible, A. B is visible, B. C is visible, C. D is visible, D. E is visible, E. So F not visible, F not visible. G not visible, H not visible. This is O. Similarly, for front view, looking from this side. So C dash visible, D dash visible, E dash visible, F dash visible, G dash visible. Here not visible, B dash bracket, A dash bracket, H dash bracket. That's all. So after this, you can show the dimensions on this. So here how much, what is the length? How much length? 60. Don't write mm, only numerical. Then again the diameter you can show here. So diameter you can show in many, there are different methods to show the diameter, dimensioning of diameters. So any one method you can apply. As you know, dimensioning line should be minimum 10 mm away from the object. So what is diameter? 50 mm. This is the symbol for the diameter. So now that completes the construction of a circular cone when the axis is perpendicular to both HP and VP. And here again you have to show the dimensions because it is given the center is how much distance? 35 mm above HP. 35 mm above HP, and the base is in front how much? 25 mm in front. Base is in front. That means not axis, the base distance. In front, sorry. Here itself. This distance from x dash y dash, not from the center, from the nearest corner, nearest point is 25 mm. Okay, that's all. Now, so you can practice cylinder and a cone. You can practice a cylinder and a pyramid. You can practice. So here there is a prism. So this you can, a pentagonal prism of base side 30 mm, height 70 mm is resting on the HP on one of its edges with its axis parallel to both HP and VP. So here condition HP and VP, that is axis, parallel to both HP and VP, correct. And true shape is obtained inside you, resting on side. So on the flat side you are taking. So here construct the pentagon, then reference line XY, X dash Y dash, intersection point 45 degrees, projections downwards, then projections, okay, that is you can say left side, then again projections left side for to obtain the front view at convenient distance first line. Okay, then what is the length given? 70 mm. Close here. So here you get one rectangle, here also you get one rectangle. So notations, be careful to while writing the notations. Okay, this is how to construct a pentagonal prism resting with its base on HP, base side on HP. Right. Now again cylinder, similar to the previous one, it is cylinder. Draw the projections of the cylinder, 50 mm diameter, height 60 mm, lies such that its center is 40 mm above HP and 40 mm in front of it. Center, in the previous question, it was the base was nearer, 25 mm nearer to VP, but here it is given center is 40 and 40. So here first draw the axis line, circle, from the center of the circle, this O, center of the circle, at a distance of 40 mm x dash y dash, then at a distance of 40 mm xy line, intersection point, okay, for O, 45 degrees inclined line, divide the circle into 8 equal parts, downward projection, left side projection, again projections towards the left, then at convenient distance first line, then length is 60 mm, close it. Here you will get one rectangle, here also you will get a rectangle, and be careful while showing the notations in front view and the top view. For front view, looking from here. For top view, looking from the top. Okay, that's all. Thank you.